And broadcast.
The broadcast is now starting. All attendees are in listen-only mode.
Hi everybody, welcome to our Fledermaus webinar this evening or this afternoon in Australia. It's late evening here in the US. I'm going to just start my little presentation here. My name is Erin Heffron and I am a product specialist for IVS 3D. I'm going to start out just showing you some basic stuff about using GoToWebinar, how you can interact with us, and then we're going to turn it over to Doug Bergersen, who is going to be the presenter today. So like I said, the presenter is Doug. He is our Regional Managing Director at IVS 3D Asia Pac. As panelists, you have me and also Mo Doucette, who is the Chief System Architect. Mo did a lot of the work on the interpretation tool that Doug is going to be demonstrating, as well as the ArcGIS integration. So Mo and myself will be fielding questions that come in over the chat, and we'll also be here to help Doug out if he needs it. But if you have questions that you want to address to Doug, I'll show you how to do that in a minute. So you should be seeing something that looks a little bit kind of like this. You have your GoToWebinar viewer, and that's where you'll see the presentation and as Doug does it. And then you also have a little GoToWebinar interface thing, and that would be here on the right. And that's what it looks like in Windows. It looks a little bit different depending if you're on Mac or Windows. So to participate in our webinar today, this little orange arrow will open and close your panel. So if it's in the way of what you're trying to view, you can close it. Click the arrow, it goes in, click the arrow again, and it will open up. You have preferences up at the top if you want to change it to full screen or anything like that. You can use the preferences in the view. For audio mode, I think most of you are on mic and speakers, meaning you're using the voice over internet protocol using either a headset or your mic and speakers built into your computer. You can also use a telephone to call in. If you're going to use a telephone, you have to physically switch over to use telephone. The audio setup also lets you choose if you're using a headset or using your built-in mic or speakers. If you want to use the telephone, if you click on that, it will give you the phone number for the webinar, and that will connect you directly to us. If you want to ask a question, you can type it in the question dialog box. You guys are all on mute by default to keep it from getting too crazy, but if you do want to ask a question, feel free to type it in. And if you want to verbally ask a question to Doug or one of the panelists, you can raise your hand by using the little hand icon. So you click on that, and I'll see that you want to ask a question. And when we get to a good stopping point, I will stop the webinar and ask Doug to talk to you. So we'll be continuously addressing the questions in the text box as they come in. If we get a good one or a difficult one, we may ask Doug to take care of it. And if we don't get to your question, I will definitely make sure and email you within a day or two with the answer to your question. If you have any webinar requests, comments, or ideas, things that you would like to see as a presentation, you can email me, eheffron@ivs3d.com, or use the GoToWebinar at ivs3d.com. If you have questions about Fledermaus or if you want to do an evaluation, it's best to use the info@ivs3d.com email. If you are a client and you have bugs, feature requests, and other client support, please email support. All right, so that is the end of my discussion. Doug, I'm going to change the presenter over to you.
Okay.
And then you can get started.
All right. Let me know when it's up on your side.
We do see your screen.
Okay. I'll just start my little PowerPoint presentation. Thanks, Erin, and hello, everyone. The content of this webinar is intended to be very practical in nature, and will hopefully highlight some of the capabilities that have always been a part of the Fledermaus suite, but they've certainly been improved upon with version 7.2, and will continue to be developed in response to some of the industry requirements and trends that are evolving out there. As per the standard webinar format, what I'll do is I'll first lead you through a brief PowerPoint presentation before providing a demonstration of the interpretation tools themselves within the software. So what we're going to cover in this webinar are these different stages of doing an interpretation. The interpretation preparation, which is essentially gathering all the existing information and combining it with any new survey data that's out there to build a scene that you use as part of the interpretation, so you're getting an overall view of all the information across the area. Then we'll take a look at interpretation components, the data objects that go into building an interpretation. Those are essentially point, line, and interpretation data objects. Then we'll take a look at the interpretation procedures, how you go about capturing Seabed features as points, polylines, and polygons. And then we'll take a look at some of the interpretation deliverables or export products that you can get from each of the data objects and how those link into eventually the ARC world. Okay, so all the interpretation tools I'm going to be talking about are a standard part of the Fledermaus baseline bundle, the FMViz 4D bundle. There are some other software IDS applications that can augment your interpretation efforts, things like FMGeocoder for doing the backscatter mosaic, angular range analysis for the Seabed characterization, and some statistical analyses of returns from the Seabed. You have FMGIS, which can assist in transferring and loading between ARC workspaces. And then to a lesser extent, FM Midwater, which can be used for processing and analyzing water column data, which may be a part of a survey interpretation, especially if you're working with geohazards. And you also have an indirect capability to work with your sub-bottom profiler data in FM Midwater. Okay, so let's take a look at interpretation preparation. And again, this is just the building of a scene so that you get an overall picture of what's going on across the survey area. So if you're working with gridded or ungridded bathymetry or topography data, you'll be creating a DTM data object. If you're working with gridding up any other type of data that isn't bathymetry or topography, you're going to be creating a scalar data object. This could be in the form of backscatter data or rugosity, slope, gravity, magnetics. Again, anything that's going to be presented in a gridded form that isn't bathymetry or topography that gets stored under a scalar data object. If you do have imagery of any type, that can be brought in as an image data object. So again, this could be a geotiff of a mosaic and drape that on the seabed, or it could be a chart, it could be satellite imagery, could be photographs at the bottom. All these can be registered relative to your other data and help, perhaps help guide your interpretation. You can also bring in information as points. In this case, we're looking at the presentation of the angle range analysis from FMGeocoder in its current state. So what we're coloring the points by are different sediment types or sediment classifications. So the greens represent silts, yellows are sands, and oranges are coarse sands. You may not have the this sort of seabed classification. Maybe you've got just individual grab samples or cores across an area, but again, these can be brought in as a data object, maybe a point data object, and colored according to maybe sand percent or silt percent, or add a label to them. Again, just to help guide you when you're conducting your interpretation. You can also register an existing interpretation as a line object, or the other type of information people tend to bring in is sub-bottom data, and these are generally brought in as vertical curtains, and you can play around with the transparency on your DTMs to show your sub-bottom data relative to your surface data, and this may help you make decisions about what's going on across an area. So I did throw in this slide because one of the questions I'm typically asked when I'm either providing training or working with different survey groups is how do you register your sub-bottom data? Well, there's three different ways to do it. One is to import a TIFF image of the sub-bottom profile as a vertical image, and that's just through the import menu option of Fledermaus. Just import vertical image, and then you register the start and end X, Y, and Z information, and that just hangs as a vertical curtain. You can also use the FM command tool if your start and end of your profile isn't along a straight line, then maybe using the FM command make vcurtain command operator is the way to go, because here you're going to register your image file with an actual XY navigation file, and then you assign how those XY points relate to the different columns of your image file, how they get distributed. So you can, this is one way you can add curves to the image itself as it's registered in the Fledermaus scene. Finally, there is limited support within FM Midwater to work with seg-Y data. It's something that's I guess continuing to be looked at by the development group, but this is another way that you can use an IDS tool to automatically create vcurtain data objects, and they just drop directly into your scene. So looking at the interpretation procedures, once you've got your scene built and you're ready to start your interpretation, the majority of interpretation is probably going to be done with the new interpretation data object that was added in version 7.2. So this is a way you go about capturing polygonal areas across your seabed. Now, to add an interpretation data object, you simply go into the Create menu option of Fledermaus and select the Add Interpretation menu option. And once you do that, within your scene, you'll have created an interpretation data object. And over in this area, you can see some display options associated with the interpretation data object. The first thing you'll probably want to modify is in this panel here, which is the key names or class types across the survey area. So this is where you define what types of seabed classes exist or you want to be a part of your interpretation. By default, you're going to come up with an unclassified type. To add additional ones, you just click on the Edit Keys button and you'll launch this dialog, which basically comes up with, by default, an unclassified type, and then you just click on the Add button to add more class types or key field names. And if you want to change the names assigned to each of these class types, you just double-click in the key field value, type in a name, double-click on the color panel to change the color assigned to those particular class types. Okay. Other data objects that we'll be using as part of our interpretation are line data objects to capture linear features, things like anchor scars, sand wave crests, faults, those sorts of things. We'll be using point data objects to capture point features, so these could be rep locations, pock marks, spot depths, anything that can be or you want to assign as a point. And then generally I will also create a parent data object which I'll use as just a storage entity for all my other interpretation data objects. Just keeps things nice and neat within your scene, within your data objects control panel, your data object stack. Okay, so I'll drop out of the PowerPoint now and we'll take a look at how you go about conducting an interpretation within Fledermaus. So let me go ahead and launch Fledermaus, and I'll open up an existing scene that I've built. So here's a scene I've created with a bunch of different types of data objects. So what I've got here initially showing is my a DTM data object. Again, what I can also bring in here are things like mosaic backscatter imagery, and you can see how the backscatter data highlights different features across the seabed that aren't quite apparent or readily apparent in the bathymetry itself. So I'll use this as a basis for my interpretation. Other types of data objects we can work with are image data objects. So here I brought in a chart and draped it on top of the seabed, and again this might highlight where I've got certain things that I want to include in my interpretation data object. I've got some angle range analysis information brought in as a point object and color-coded the points according to the seabed type. So I'll just turn on my mosaic again, and we can move down, and you can see that, you know, in general, some of the darker areas, lower backscatter areas of my mosaic correspond to the green dots, which are my silts. The higher backscatter areas correspond to the yellow dots, which are sands. So I've basically colored these points according to this color table I've set up for ARA, where my greens are silts, yellows are sands, oranges are coarse sands, and these are all fee sizes. Again, if you didn't have a seabed characterization type file, you could also bring in things like cores, represent those as point objects, and again use those to help drive where you draw your boundaries in.
Hey Doug, sorry to interrupt. We're just a few seconds behind on the update. It hasn't been too bad yet, but just, I don't know if you could see your audience view part of the screen. It's a little...
No.
Okay, of course not. Well, it's probably maybe a 3-second update, so just if you can keep that in mind. If anything gets really out of whack, I'll give you a heads up, but it's going pretty good.
Okay, I'll slow it down a little bit. All right, the final data object I'll show is a V-curtain data object, and again, this is just a just change my transparency of my bathymetry. This is just a sub-bottom profile here that again you can use to see how your sub-bottom data is relating to your surface data. So you can play around with your transparency here, and you can see that we're getting a sediment unit in between these two rock sort of units. Okay. So what I'm going to start out with for my interpretation here is I'll start off with just my mosaic and my bathymetry showing. Widget here. Now, typically when I'm going to conduct a mosaic or conduct an interpretation, what I'll do is I'll rotate myself to plan view, so I can either do that manually or you can go into your exploration menu option and click on plan view, and it'll snap you to a plan view of your scene. So the first thing I'm going to do is I'm going to create a parent object, which will allow me to just store all my different other interpretation data objects I'm going to be creating. So to create a parent object, I just go into my Create menu option and select Add Parent. And again, this is just really my little convention for keeping track of everything that I'm creating. So I'll just rename this parent object, just right-click on the parent object, rename it, and I'll call this give it my survey name, so this is SSO8, and I'll call this interpretation. Click OK. So that's essentially just giving me a folder under which I can store other data objects. Now, what I'll do is I'm just going to focus for the meantime on this little area up here just to show you how you can start to capture polygonal areas across a seabed. And the data object I'm going to store those polygonal areas into is an interpretation data object. So this is a new data object that was added with version 7.2. So to create an interpretation data object, we just go into the Create menu and select the Add Interpretation option. that's classic. Okay, let me just bring that back up again. All right, so just bring up SSO8, turn on that guy. I'm not sure what happened there, but give it a try again. Okay, so I'll just create my parent object again. Create my interpretation data object, and this is what you should see. Now I'm just going to left-click and drag my interpretation data object underneath this SSO8 interpretation parent, and now you can see that it's just stored under there. Okay. So with the parent data object or interpretation data object, what we have here is a display panel, which we'll use to help highlight the polygons that we're creating. And then you've got this key field, key panel here, which we'll use to define what sorts of sediment types or seabed features we've got across the area. So the first thing I'm going to do is we start off with an unclassified. I'm going to want to add a list of the different class types or key types that we've got across the survey area. So the way I do that is I just go over to my Edit Keys button, click on that, and I open up that Interpretation Key Fields dialog box. Now to add additional key types or class types, I just click on the Add button, and I'll add 3 or 4 of these guys. And to assign a name to the key field, I just double-click in the panel and type in the different class types I've got across it. So I've got some rock, got some sand, silt, and let's say clay. Okay. And now I can go about assigning different color types to the different class types. So I can double-click in the color box, change my unclassified maybe to a purple color, change rock to red, sand to yellow, silt to green, and clay to a brown. Now when I click OK, you'll see that information registered in the key field panel. Now, if you wanted to, at this stage, in order to prevent you from having to register these sorts of class types every time you do an interpretation, what I can do is I can actually save this interpretation data object to my hard drive, and then when I start to work in a new area, I can just load that interpretation template into my scene, and that allows me to very quickly and easily repeat the different class types that I've got assigned that apply to really any survey that I'm doing. So just to illustrate how that works, to save this sort of empty interpretation right now, I just right-click on it, save the object as, give it a file name, so I'll call this template 2. Click Save. And now if I delete this data object, just right-click and select Remove Object. The next time I open the data object, you'll see that, so I'll just select Interp 2, you'll see that all the colors, all the class types have been retained. Okay, so it makes it very quick and easy to begin an interpretation in a new area as you conduct a new survey. Now, to actually start to use, to assign polygons to this interpretation data object, the way we're going to do that is we're going to go up into our control bar, and we're going to go into one of our selection modes up here. Now, the 3 selection modes you have for defining polygons are, you've got the select mode, which if you click on that, left click and drag, you draw a box. I don't use this very often because normally the seabed features I'm interpreting aren't box shaped. So generally I'll either use my polygon select or my area select modes. So polygon select, you just left click and you lay in a bunch of vertices, and if you want to create a closed polygon, you just move towards that first vertex. You'll see the little triangle become opaque. You can see it's empty right now. Now it's opaque. That means it's going to create a closed polygon. Okay. So that's one way you can do it. The one I tend to use the most is the area select, which is really just allows me to do sort of a free-form drawing around a feature, and it's going to by default create a closed polygon. So let's say I want to digitize around this dark feature here, which we'll assume is a silt. So to do that, I'm just staying in my area select mode, and I can do just sort of a quick drawing around it because we'll be able to modify the polygon as we go along. Okay, so drawn a polygon around that feature, then I just select which class type it relates to, or the key name. So I click on, in this case, silt. And then I just click on the Add button to add that polygon to that class type. And you can see that the line itself becomes green, which corresponds to the color assigned to the silt key name. All right. Now, you can use some options here in the display panel to make the lines a little bit more prominent. So you can increase the line width, the little slider bar. You can add sort of a false vertical offset just to bring it a little bit above the DTM, so the line becomes more prominent, and that just helps you see what you're digitizing across. Now, if I wanted to draw around another class type, let's say I'm interested in digitizing around this rock feature here. Again, I'll just stay in my area select mode, left click, drag around the rock feature. This time I'm going to select my rock class type, click add, and now I've assigned that polygon as a rock area. Now, one of the neat things about the interpretation tool is that you have the ability to automatically create seamless boundaries between different class types. So let's say that I wanted to assign this area between the rock and the silt as a sand type. Again, I can just use my area select. I don't need to be careful about matching up my boundaries just so that they overlap. And I can draw along here. Okay. And let's say I want to define that as sand. I just click on my sand class type, click add, and you'll see that it automatically creates a seamless boundary between the rock and the silt. Now, if you want to start to modify your polygons, another neat capability of the interpretation tool, as built by IVS, is a technique that we call nodeless interpretation, which is the ability to, if you want to modify the edge of a polygon, you don't need to select individual nodes and start to move them around. It's really just like painting on top of a surface. So if I want to extend this portion of the silt unit out to encompass this darker section here, all I do is, again, draw around the area I want to include as part of the silt. And in this case, what I'm going to do is I'm going to grow the silt polygon outwards from the current bounds. Okay, so that means I'm going to add on to the silt class. So I just click add, and you can see it removes that boundary there and just extends the boundary out to include the area that I just drew around. If I want to remove an area from an existing polygon. Again, I just draw around the area I want to remove. So let's say I want to move this bound here of my silt unit inwards. Rather than adding onto it, I'm going to remove this time, and it just shifts that boundary in. Now let's say I want to extend the sand unit out a bit farther here. Again, all I do is draw along. Say you don't need to be overly careful with staying on your DTM itself. If I want to extend that sand unit, now I just click Sand, click Add, and it's added in this portion here. Okay. Now let's say the case where I've got a class type within another class type. So in this case, I've got silt area within my sand unit. Now there's a couple ways that you can manage this. I'm just going to zoom in on this little feature here. One way is it's a two-step procedure, is to create a hole in the existing regional class type, which would be my sand, and then fill that hole with another class type. So the way you do that is you just draw around your area. Okay. And what I'm going to first do is create a hole in the sand unit. So I'll click on Sand and click Remove. And what you'll see here is a bunch of little diamonds appear. These refer to this marker size attribute within the display panel. Now, as you increase or decrease your marker size, that's just going to increase or decrease the size of those little diamonds. So you see more or less, resolution of the edge of the boundary you've just drawn in. So this is a hole within the sand unit. What you can see in between each of the little marker vertices, there's no connecting line here. So that's going to say if I created a filled polygon representation of this interpretation, you'd end up with a blank area here because that hole isn't filled with anything yet. Now if I want to fill that hole with a different class type, I just draw around the hole, and I don't need to be too careful about matching up boundaries again, because I'm going to, when I fill it, it's going to automatically create a seamless boundary. So I just click on the class type that I want to fill that hole with and click Add. And now you can see that I've got a green line drawn between my yellow markers, and that's telling me that that hole is now filled with silt. Now, there's an easier way to do this if you know what you want to fill a hole with, and that's just to draw around your area of interest. Let's just do that one quickly. And rather than go through this Add Remove step, you can just click on what you want to fill it with. So I'm going to fill this area with silt, and then just click Override. And it'll automatically do the hole creation and filling all in one click. Okay, and if we extend out our sand unit here to encompass that entire unit that we had defined originally as a silt unit, and now I click on my sand and I click Add, it has automatically created that as a whole. Just increase my marker size a little bit. So that's automatically created a hole in the sand unit and filled it with silt. Okay, so that's the basics of the interpretation tool, and it does take you a little while to get familiar with how you should be moving your boundaries. But as long as you think of what you're trying to move, if you're trying to either grow a polygon or remove bits of the polygon, the Add Remove buttons here make sense fairly quickly. Okay, you can also see in your different class types here, you get a running calculation of what the total area of each class type, the area encompassed by the polygons, so you can get an idea how much area each different class type is covering.
Hey, Doug. Looking great, but Mo had something to say. So Mo, you want to come on and comment?
Sure. Just can you guys hear me?
We can hear you, so I hope everyone else can too.
Hopefully everybody else can. Just a quick tip is I think kind of the mantra is to when you're doing the interpretation is to do the little bits first. The polygonal math that has to go on when you're doing the subtraction or the overriding. If you've got a large interpretation area, sometimes you'll notice the system will take a little longer while it's doing all the vector intersections. So if possible, if it's practical when you're doing the interpretation, is to do the things that are small first, and then do your larger areas, and that'll pretty much use the system in the most efficient way. That was it.
And I think Mo was kind of quietly commenting, Doug, that you should, save early and save often as you go through your interpretation. But anyway, while we're at a pause, if anyone has any questions, now is a good time to raise your hand. We haven't had any text questions really, other than will the presentation be available? And it will be. If you're a client under maintenance, we make a PDF of the PowerPoint, and we also are recording the webinar, so both will be available within a few days. I don't see any raised hands at the moment, so you can continue on.
Okay. So that's working with capturing polygonal areas across a seabed. And again, I'll move this interpretation data object underneath my interpretation parent node, and I'll probably rename it to something that is SSO8. This would be maybe my seabed class types. Okay, so it makes intuitive sense to me what I'm doing. And you may have multiple interpretation data objects as part of your total interpretation. You might have one as different seabed class types. You might have one that represents different morphologic units across the region. So there's really no limit there. The next thing that you may want to have as part of your interpretation is linear type features. And the way that I handle that case is to go in and create a line data object. So I just go into my Create menu and select Add Lines. And that automatically got registered underneath my interpretation parent node. And so typically I'll rename the default name to something that makes sense relative to what I'm interpreting. So in this case, I'll call this sand wave crests. Okay. So to capture linear objects, what I'm going to do is I will capture linear features across this area. All I do is go in this case, I'm going to want to use my polygon select mode and just start to move across where I see sand wave crest. Okay. So that's a linear feature. I can just drag my cursor off the main viz window of Fledermaus now, and for that line object, I'll just click on the Add Polygon Selection button. Okay. Now with line data objects, you can do things like change the line width to make the polyline stand out a bit more. You can add a bit of a false offset if you want. Another thing that you can see that if I zoom in on this area here, you'll see that in portions here, because I'm just drawing a straight line between those various vertices I laid in, the line cuts through the seabed in some cases. To do a better draping on top of the seabed with a line data object, you can just click on the Resample and Drape button, and this particular DTM has a 1 meter resolution, so there's no sense in oversampling. Click OK, and now you can see that it's draped on top of the seabed a little bit more, a little bit better. You can also change the color if you want, so maybe I make this thing sort of a nice pink color. And again, you can add multiple linear objects to this single line data object. So if I want to digitize across another sand wave crest, just click Add Polygon, select. So you can see that the color of the line and the thickness of the line is captured with each new linear object I add. The only thing I may need to do is, when I'm finished with capturing all my linear objects, just go through, click on the Resample and Drape button again, respecify that to be 1 meter, click OK, and now they're draped at the same resolution on top of the seabed. Now you may also have point features across an area, and the way we manage those, so what I'm going to do is I'm going to just capture points across these depressions here. I'll just for my own sake, I'll just call them pockmarks, even though they probably really aren't pockmarks. So the way you handle point objects is you'll go to your geopicking tab on the bottom of your object attributes window, and you see this table. If there's any values in there, you can just click on the clear button, and that just clears the values that are in the table. And in this case, what I'm going to do is I'm going to go to my select cursor mode, and now I'm just going to left click across the DTM, and wherever I click, I'm adding an XYZ point for that feature. Okay, and things we can do with the information in the table, we can also add labels. So if you wanted to type in, PM1, PM2, any sort of label that you want. Anything that you want. And all these things are just written into the table right now. If we want to actually add a physical data object to our scene, you can do that through the Table Action button. Just left click on that and create a point object. And you can see you get this default point object name called internal points. And again, I'll just rename that. In this case, I'll just call it pockmarks. And with a point object, I'll just go from my geopicking tab over to my object attributes tab. I'm sitting on my point data object, and now I can change the marker type that's associated with these things. So maybe change it to diamonds. You can change the label size. So you can see then we might need to put a little bit of a vertical offset in so the labels come out from the seabed a little bit. You can see the granularity and the little slider bar is getting a little bit difficult to control the actual size of the labels. Any of these slider bars that have a button to the right of them, you can click on that button and just change the end value. So I'll change this to something slightly 0.3, and now I've just got a lot better granularity over making the label sizes whatever they want. And you can color these, change the color of the point objects to different color if you want. Color them by point height, etc. Okay, and again, I'd probably left click on that point data object, move it up under my interpretation parent object, and now again I've got everything nicely stored underneath my interpretation parent. Okay, so in general, the interpretations I do, I initially do them in plan view. But one of the nice things about working in the Fledermaus environment is you can rotate yourself up to look at a more perspective view as well, and that may help out assign where you want a boundary. So in this case, you can see much easier in the bathymetry where the edge of the rock feature is rather than in the side scan mosaic, so you may turn off that layer and use the bathymetry to derive the boundary definition more than the backscatter mosaic. So in this case, I'd want to move this edge out. Again, just go into area mode, area select mode, draw in the new boundary. If you make a mistake, you can just start over again. And maybe I want to grow this side of it out, so I just go to my interpretation data object, click on my rock unit, click add, and it grows it out. If I want to remove a bit, move that guy in, rock unit, click remove, and it just moves that side of it in. Okay, so nice and simple. So that's the basics of actually conducting interpretation. I guess we can take a pause here if anybody wants to ask any questions.
Anybody have any questions? Remember, if you want to raise your hand and ask Doug a question directly, you just hit the little hand icon. I don't see any, so you must be doing a good job.
Yeah.
Continue.
Okay. All right, I'll just quickly drop back into PowerPoint here. We'll just take a quick look at the interpretation products or deliverables. So take a look here. So what can we export out of the different data objects we've created? Well, sort of the standard data deliverables these days they're just sort of unstructured data files that you supply to a client. So out of a point data object, you can export the information as an ASCII XYZ file or as a Google Earth KML file. For line data objects, you can export those as, again, an ASCII XYZ or a DXF DWG or a Google Earth KML. For an interpretation data object, there's a couple different things we can do. We can export a geotiff of interpretation polygons, so filled polygons, show the different, in our case, Seabed class types. You can also drape that geotiff on top of the seabed and create a shaded geotiff. You can export as an ASCII XYZ or DXF or Google Earth KML. You can also generate a report that consists of class type and area and boundary length information, and that's just a normal text file. And then, of course, there's all other sorts of products you can export from the various supporting data objects as well. Now, where all of this is heading, and where some industry groups are heading, in particular the oil and gas group, is taking a more structured approach towards data deliverables, and that's working with various data models, different ESRI Geodatabase deliverables. One that's soon to be released in the oil and gas industry is the Seabed survey data model, and this slide just provides an overview of the different feature classes that they've defined for the Seabed survey data model. So you've got environmental sample feature classes, you've got seabed feature classes, shallow intermediate geology feature classes, survey measurement feature classes, and that's one of the real benefits of the ARC integration that's been done within Fledermaus, is you'll be able to populate these data models. So what a oil and gas client will do is send out to a survey group an empty seabed survey data model with all these feature types, feature classes defined in it. And as they go about acquire the data, interpret the data, they'll just start to populate that geodatabase. And then the geodatabase, along with other data products, will get handed back to the client, and it makes it much, much easier for them to register all the information into their company GIS. And this should save a tremendous amount of time on both groups for asking for reissuing of data products that they can't quite fit into their GIS and then having to resupply things. So I think it'll be a big step forward. So we'll just take a quick look at, again, how you start to export data products from our Fledermaus scene here. So with our point data objects, the way you export information is just go to the export file, and here are the different options that you have. So either as an XYZ file or as a Google Earth KML. Okay, I won't do that right now. Let's cancel that. With the line data object, you just again click on the Export As button, and the types of information you can export are XYZ, DXF, DWG, and the KML files. For the Seabed, for the interpretation data object, there's a couple of things we can do here. One is we can, when you're finished with your interpretation, you've got a couple more options that are available to you within the object attributes panel of the interpretation data object. You can fill any areas that you haven't interpreted. If you want to just have a default sort of regional sediment type, you can click on, let's say I wanted everything outside of the areas that I've interpreted, maybe define that as unclassified, or maybe the regional sediment type is clay. You can click on that, and then you can click on the fill button, and it'll draw a polyline around the remaining portions of the DTM, automatically define a polygon for you. Okay. I won't do that in this case because I'm just interested in working with these areas that I have defined. The other thing I'll do once I have finished my interpretation, if I had drawn any lines outside or off of my DTM, I'll clip my interpretation to just the extents of my DTM, whatever DTMs I have displayed. Okay, so I'll click on the clip button. Gives me a warning message saying that you're going to lose any interpretations outside of the DTM areas. So I'll just click yes. And that should, I didn't have a real good example here, but what it should have done is clip, anywhere that I extended off my the edges of my DTM. Okay. Now, if I want to create some different data deliverables, one of the data deliverables we can create is if I go into my Tools button of my interpretation data object, I can create a GeoImage. And the default resolution here will be of the DTM you're working with. So in this case, it's 1 meter. And you have these options here for assigning a color, a background color, either keeping it transparent. Again, you can assign it according to one of your class types, or you can assign a custom color if you want. I'm just going to keep it transparent in this case. Click OK. And what I've created here is, underneath my interpretation parent, is an image data object that is a filled polygon, set of filled polygons colored according to whatever class type is associated with the polyline itself. Okay, so that's just a flat image. And again, I can export this, go into my image data object here on my object attributes panel, go to my Tools button and say Export As, and save this as my SS08 GeoImage as a GeoTIFF file. Okay, and take a look at that. Another thing that we can do with this image data object is I can drape it on top of my DTM. So if I go to my SS08 EM3002 bathy data object, here's my DTM data object. To drape that GeoImage on top of this, I just go to the DTM Tools button and say Drape Image on Surface. I select that image data object. I'll use my illumination or the shading associated with my bathymetry to add shading to the draped image. I'll just do it on my current surface, but obviously you have other options available here. Click OK. and just turn off that flat image. And now you can see I've got a shaded interpretation draped on top of my DTM. And I can export this as a GeoTIFF. Just go to my DTM that it's draped on, go to Tools, Export Surface as Image, and I'll call this SSO8 shaded GeoImage. And these guys look like, let me just bring this up. So here's my GeoImage, and here's the shaded GeoImage. Okay, so again, both of these are GeoTIFFs. You can drop them into your GIS or other charting package, and you're ready to go. Other things we can export out of an interpretation data object are, again, just through the Tools button. You can export your polygons as an ASCII file, okay, or as a simple XYZ ASCII, or as a DXF, DWG, or KML. You can also generate a report, export report, and we'll just call this SSO8 report. And what's included in there is this information. So your class types that you've defined, the area, and the boundary length associated with the polygons. Now, we mentioned the link to the Arc workspaces. If you have an ArcGIS license active on your system, with the 32-bit version of Fledermaus, you should see, or if you have a FMGIS license as well, that's our connection into the Arc world, you should see for any data object an ArcGIS button. So with a DTM data object, I've got an ArcGIS button. Point data object, I've got an ArcGIS button in the Object Attributes panel. Line data object, there's my ArcGIS button. And my interpretation data object, there's my ArcGIS button. So this is how you either this is how you'll transfer information from the Fledermaus world, from Fledermaus data objects, into an Arc workspace. The first thing I need to do, though, is I'm going to create an Arc workspace data object in my scene and create a geodatabase that I can write these things into. Okay, so to create an Arc workspace, you just go into the Create menu option and select the Add ArcGIS Workspace. I'll just move that out of my interpretation parent here. And in this case, I'm just going to create a geodatabase. Okay, so these are the different workspaces you can tap into, either a folder, in which case if I was transferring point or line objects in, I'd just be creating shape files. In this case, I'm going to create a file type workspace, which is a geodatabase. You also have options for, excuse me, personal workspace, which is a Microsoft database type workspace, and then an Arc Spatial Data Engine. Okay, so in this case, I'm just going to create a geodatabase. So I'll just click Create. Give it a name. We'll call this Webinar Geodatabase. Click Save. And then I'm just going to connect into that geodatabase. And now I'll be able to write any information from any of the data objects into this geodatabase. Likewise, if somebody had given you a geodatabase, you would create an ARC workspace data object in Fledermaus, and then rather than having to go through and create one because it already exists, all you do is just connect to it, point at whatever you want to connect into, and that would allow you to pull information over to a Fledermaus scene. Okay. In this case, what I'm going to do here is I'll show you one way that you can, if you have an interpretation data object, what we can do to transfer all that interpretation over to the ARC workspace. You just click on your ArcGIS button, transfer interpretation, give it a name. I'll just get rid of that underscore there. Click on the workspace you want to tap into. So this is going to tap into that webinar geodatabase we've just created. Click OK. And now that's been written into that geodatabase. Now, if at some time I wanted to bring that interpretation back into the scene to modify boundaries and such, so what I'll do is I'll remove the current interpretation data object that's under my interpretation parent. So I'll just remove that object, okay, and recolor my bathymetry DTM according to just the bathymetry. Okay. Now, if I wanted to sometime later bring that interpretation that I've stored in the geodatabase back into the scene, modify it, and then write it back out to the geodatabase, the way you do that is click on your ARC workspace. Here's the interpretation that was written into the geodatabase. I just right-click on that set of polygons, load the scene, and I'm going to bring this in as an interpretation rather than as a 3D line. So anytime I'm transferring information from the ARC world back into the Fledermaus world, depending upon the feature class that you've selected, you'll have different options here as far as how you want to transfer that feature class back into the IDS world. Okay. Now, one thing that may have changed as we shift from the ARC world into the Fledermaus world and vice versa is the colors that are assigned to the different class types. If we want to recover our original colors, all we have to do is click on a color from template, point ourselves at that interpretation template we created, click open, and now those colors are reassigned. Click OK. And under this ARC workspace data object, I now have my SSO8C class interpretation data object. That gets brought in initially at a 0 height, but I've got a drape button on the interpretation data, the object attributes panel. Click drape. Now my polygons are back on top of the seabed, and again, if I want to modify things, just go in using my area select tool, draw around, click on the class type, click add, shift it out, and I can go back and write this back into your ARC workspace. Okay, so that's a general overview of how you go about conducting an interpretation in Fledermaus and how you start to create different data deliverables and start to move different information to and from an ARC workspace. If anyone has any questions, happy to try and answer them now. Otherwise, that pretty much wraps up the webinar.
Hi, Doug. We do have some questions. Some of them I asked are answered, but I will probably ask a few anyway, because if one person's wondering about them, many people might be. We also have Brian Davey, who's going to verbally ask a question, because I wasn't quite sure what he was getting at. So, Brian, I will unmute you first and get you up. So let me just find your name in the list. All right, Brian, I'm going to unmute you. Hey, Brian, can you say hi?
Hello? Can you hear me?
Yep. Go ahead and ask your question.
Yeah. Now the question is, sometimes we'll put track objects, line objects marking where we want, say, tracks on the seafloor, and then we change our minds and we want to move them over a bit, perhaps using the translate tool under edit. When we do that, can we then just save that straight out to an ArcGIS, or does it preserve that translation in the object as it goes out?
Yes, it should. So if I if I went down to these line objects here, clicked on my sand wave crest, the edit buttons he's talking about are over on your control bar. Translate, move these over, and then probably what I'd do is I would save the object again, just to make sure that those are registered, and then for that linear object, ArcGIS transfers lines, I'll put it into that Geodatabase, and those translations should be, ooh, interesting. Don't know, Mark, Mo, do you want to comment on that?
Yeah, no, that since it's an internal translation, I'm trying to think if it's going to actually preserve it if you don't save it. If you save it, it should preserve. Can you
save that?
And obviously the reason I ask is I've had some problems and I'm not quite sure. I was wondering whether you needed to save them or something like that before you exported them.
Yeah, because it has to recompute the actual points. That's it. You know, I'm gonna look into that for you.
Yeah.
Great.
I mean, it should usually, as you export it as an XYZ, it retain, you know, it does register those new locations. Yeah.
Right.
That time it seemed to register it. And if let me just I'll try and remove those.
Or leave them so you can match them, Doug, to see if you can correlate them.
Okay, yeah, I'll bring them back.
I'll certainly go.
Okay, so that's there, and then try and bring them back in from the Geodatabase. So there's the sand crest. Load the scene, and that's fine. Oh, you're right. Okay, Brian, sorry. It wasn't retained.
Okay.
And I think that's because that's a separate transform to the ESRI object. Yeah.
All right,
Okay.
so looks like a bug, so we'll
Good bug.
register that, Brian, and we'll get back to you with the case
Yep,
number and
thanks
all
very
that
much.
good stuff. Thanks for being the guinea pig on the vocal side. All right, Brian, I just muted you again, but feel free to raise your hand if you have any other questions. I have some text questions that I was just going to read out loud for everybody, and between Doug and Mo and myself, maybe we can answer them. All right, starting with this one. Can we see a table being edited? I guess that would, we don't really edit tables, so you would do the table editing in ArcGIS. Am I right there?
Yeah, there's no continuous dynamic, you know, connection to the GIS. So if you push data into the GIS, then there's a feature class in the GIS that's now separate from the SD object that's in Fledermaus. So if it gets modified within ArcGIS, those changes are not going to be seen until it's re-imported back, and the same vice versa. There's not a continuous connection. You'd have a significant performance degradation if you tried to do that. So they are separate. You know, when they push in, we're pulling feature classes out, and converting them over to SD objects and vice versa, SD to future.
Okay, another question. Do you have to match datum between FM and GIS, or does it transfer the datum from the FM side?
That transfers over. So there's the codes. We're either using the direct codes between Fledermaus and ARC for the datums, and if there's custom ones, then the custom ones get transferred over. So that's handled seamlessly on the object side during the transfer. It's nothing that you have to do yourself.
Okay. And any of you guys that we're answering questions for, if we didn't quite answer it, feel free to throw your hand up in the air or, send another question, because I'm just going to keep plowing through the text questions. Can we save rasters from Fledermaus to ArcGIS? Doug, you want to demo that?
Yep. So here's a, yeah, we can do the bathy unit, I guess. So we can just, again, you click on the DTM data object of interest, click on your ArcGIS button, and you can save it as a bathy raster or an image raster. Depends which one you want. The bathy raster, click on the workspace of interest, and then transfer it into the into this. This happens to be the Geodatabase. Click OK. And we wait. Okay. So you can see that it's created as a bathy raster in there. So if I turn this one off and then just bring it back from the workspace, right-click, load to scene. We'll bring it in as a surface. These are the different data objects we could create out of this. So I'm interested in bringing it in as a surface, which is essentially a DTM data object. Click OK. And then loads that DTM with the default color palette that's associated with my session of Fledermaus, which is if I click on that guy, it's just the step 16.
Okay. Next question. I think I'm pretty sure this had to do with the area calculations with the polygons that we do with the interpretation. Is elevation considered in that area computation?
No. It's a planimetric calculation. And correct me if I'm wrong, Mo, but I think the reason we opted for that is that we wanted our areas to match what you're getting reported in ArcGIS.
Okay. All right. We might have lost Mo, so we're on our own, Doug. Watch out.
Okay. I can make up anything now.
All right. Let me see. They just keep coming. All right. What's the maximum XYZ data Fledermaus can handle? I have other than 10,000 by 10,000 grids, so you must know that we do have a limitation of 10,000 by 10,000. In 7.3, it is going to increase. Doug, did you have any other comments on that? It's the XYZ data itself. Doesn't really matter.
That's the 10,000 by 10,000 is the rows and columns. So depending upon your bin size, you can accommodate larger or smaller areas depending upon the resolution you want, or you can build multiple blocks across an area, and that's another way to.
Right. Yeah. So the XYZ data set is we can't necessarily put a limit on size of the data set. It's just the resulting grid cannot be bigger than 10,000 by 10,000. And with a PFM object class, then it's a little bit different, but that's a whole other bag of worms.
And the interpretation itself can extend across multiple DTMs. So you aren't restricted to a single DTM with your interpretation.
All right. Can you import an existing classification, say from ARC, into a scene? So you demonstrated that you can put our classification into ARC and bring it back. If you were doing a polygon classification in ARC, would you just add it as an interp class and then it would become editable in our interp tool?
Yeah. Yep, that should be the case.
Okay, that was that one. Let me see which ones we've answered already. Are there 3D connections to ARC scene?
No. There's not. Now we're trying to save you from the pain of ARC scene.
All right. Okay, this one I'm not sure if I quite understand, so I'll ask it and see if you guys understand, and if not, maybe we can get Matthew on the line if he's still available. Are you able to use the geocoder capability for backscatter data to auto-interpret once you have identified the characteristics?
I think that's something Mo can probably answer better than I. I know it's been discussed in relation to the new implementation of Geocoder. Yeah, I'm not quite sure.
Yeah, I think if the question's about basically using interpretation ground truth to modify the output of the ARA, is that kind of what you're looking for, and then have ARA automatically do its adjustment? That's currently not in the shipping geocoder. It's a feature for the follow-on geocoder to enable you to basically identify ground truth and then help adjust the ARA from that. Hopefully that.
I'm not positive. It might have been too going down the road of can you use the ARA to do some
automatically draw polygons.
Yeah, that's what I was thinking.
Yeah.
Oh, no, because of the nature of ARA. The granularity of ARA is much broader across the swath than something that you can physically go and pick. With that said, another thing that's in the pipeline is for us to use ArcGIS's image segmentation. So what you could do is you could do a segmentation of, say, backscatter scalar, then bring that segmented image into Fledermaus and identify classes from that. So that's probably the closest thing. But that's a different, segmentation is very different from the way ARA is working.
Okay.
So hopefully that helps.
Hopefully. ESRI export still only 32-bit systems, yes. Mo, did you want to talk about that a little bit?
Yeah, it's just their server. They do have a 64-bit version of their server. We asked at the last ESRI user conference last summer in San Diego, there was a bunch of us that stood up and raised our hand and said, will version 10, what's the pipeline for 64-bit support? And the only answer we got out of them was it's coming for the desktop tools. And that's we're still stuck 32-bit for both the desktop tools and consequently their SDK that we use to talk to the Geodatabase. So we're kind of waiting on them for that.
All right. Matt had asked, can you calculate areas or volumes of the classification types? And I think all of you guys saw the answer, but it is calculating areas on the fly as you add to the interpretations. And Doug can show you that on the interpretation object quickly.
Yeah, these are the areas that are being calculated on the fly according to what you're drawing on. So if I change my change the bounds of my sand unit here, let's draw it out a bit more. What you should see is this value increase. And that becomes available to you text form via the export report menu option.
And that information is also transferred to the ArcGIS, so you'll have that in our catalog in your attribute table as well.
Yeah.
And then the last question was about export of lines and regions, but you went through that. We can export as ASCII, and in the case of lines, we can do DXF. Points and lines you can do as KML, and the ArcGIS stuff can all be polylines, point class, or polygons. Yes?
Yep.
All right. I think that's all. Let me check for hands that are raised. Don't see any. Thank you all for attending our webinar and staying 20 minutes late. If you are a client under maintenance, you can download the recording and also a PDF of the PowerPoint. I usually have them up on a download site within a few days afterwards. You just have to send an email to either go to webinar@ivs3d.com or ehefron@ivs3d.com, and I can send you the download information. And if you've downloaded in the past couple months, it's the same website. We just keep loading things up there. Doug, did you have anything else you wanted to add?
No. I mean, I think it's the interpretation data object and the interpretation tools that are available in Fledermaus, I think, are a pretty slick way of doing these sorts of seabed classifications, characterizations. Yeah. It's become a much more powerful piece of software now.
Cool. Thanks for doing the little webinar tutorial for us. And again, if you're interested in the recording, just let me know. ehefron@ivs3d.com, and we'll get it to you. I think I addressed any questions. We will log that bug and get back to you, Brian, about the case number and expected fix on that. And if anybody else has any questions, always feel free to email either myself or support, and we will get back to you. And that concludes today's webinar. Thanks again, everybody, and have a lovely afternoon in Australia and evening for the few people who are logging on from New Hampshire. Thanks.